Alright, so this video is about combinations. And first of all, a combination is a grouping or an arrangement where order does not matter. Alright, so think about a deck of cards, the cards you have in your hand, or an arrangement of people on a team. Whoever comes first and last doesn't really matter. So it's just a grouping where order doesn't matter. The formula for combination is a combination of m total objects. This is the number you're choosing. So this is the total objects in the set, and this is the number you're choosing or selecting from the set. The formula for that is m factorial divided by m subtract n factorial times n factorial. So this extra n here on the bottom makes it a smaller number than permutations because you're dividing m factorial by one more thing. Anyway, let's actually do an example that involves this. So I'm going to erase this. You might want to copy down that formula because we're going to be using it for the next few days. All right, somebody leave the screen. Okay, so a team of 5 people is to be formed from a group of 11 people. How many possible teams can be formed? So I'll first read the question. I'll decide whether or not is a permutation or combination. And you decide that by deciding whether or not order matters. So if you got a team of 5 people, does it matter who gets selected first, second, third, fourth, or fifth? No, because no matter what, it's still the same team. So if that's the case, it's definitely a combination. If m choose n objects. In this case, my total number of objects is 11, and the group that I'm choosing is 5. So it's a combination of 11 objects choosing 5. So this is 11 factorial divided by 11 subtract 5 factorial times 5 factorial. This is 11 factorial over 6 factorial times 5 factorial. And I'll use calculator for that. That's equal to 462 teams that can be formed using those requirements. Okay. Got a new example. I'll get into that as a note though. Moving on. A pizza can have 3 toppings out of a possible 7 toppings. How many pizzas can be made? So if that's the case, I'm outside. Okay, does it order matter? Does it matter when you put on the pepperonis or whatever the top, bacon and whatever the topping may be? It doesn't really matter the order you put it on. It's still going to be the same pizza. So in this case, order doesn't matter. So it's a combination. So it's a combination. We got 7 options. We want to choose 3. So 7 factorial over 7 subtract 3 factorial over 3 factorial. So 7 factorial over 4 factorial times 3 factorial. And that's equal to 35 different pizzas. All right, so that's how combinations work. And now let's look at another type. I'm going to make it a little different for you though. So here's a new example. All right, new question. A committee of 5 people, so we got 5 people we're going to have a committee with, is to be formed from 12 students. How many committees can be formed if Jerry and Ella must be on the committee? All right, so does the order matter? No, committee is like a team. So the order the person was selected didn't change their place on the team. So it's a combination. We got 12 people to choose from. However, 2 of the 5 people have already been decided. It's Jerry and Ella. So are we really selecting 5 people? No, we're really selecting 3 people. So it's really a combination of 12 choose 3. So it should be 12 factorial over 12 subtract 3 factorial times 3 factorial. 12 factorial over 9 factorial times 3 factorial. That's 12. And that is equal to 220 committees. That can be formed given those requirements. Okay, got a new question. All right, a team of 3 boys and 5 girls is to be formed from a group of 10 boys and 11 girls. So it's really two combinations. There's one combination of boys and there's a combination of girls that can be selected. So it's a combination of 10 boys and we want to choose 3 times the combination of 11 girls and we want to choose 5. And you may ask, well, why is the multiplication there and not addition? Well, I won't explain that in just a minute. I'm going to finish getting this answer first though. Alright, so the answer here would be 10 factorial over 10 subtract 3 factorial times 2 factorial times 11 factorial over 11 subtract, I'm going to call that 6 factorial times 5 factorial. 11 subtract 5 is 6. So anyway, the final answer here should be 55440. Alright, so that'll be final answer. So it's that many different teams. Alright, so the question probably was, why do you multiply these and not add the combinations? Because just boys and girls when the two sections be added together. Well, let's think about that with smaller numbers. Alright. I'm going to need more space than that, so I'm going to put it here. Let's say we got 2 groups. This is group 1 and this is group 2. And these groups consist of people. Let's say in the first group we have Neil, John, and Owen. And in the second group we have Sarah, Jermaine, and just to keep it simple, we'll keep it there. This is group 2, this is group 1. And let's say I needed to choose a team with 2 people from group 1 and 1 person from group 2. Alright, so the reason why we had to multiply there is this. If you think about that, my team from group 1, it could be Neil and John. Alright, and then that 2 people could be matched up with Sarah. Or it could have been Neil and Owen, and those 2 people would match up with Sarah. Alright, so, or we could have gotten John and Owen, and those 2 people could match up with Sarah. Alright, so let's think about it this way. It could have been Neil and John plus Sarah. It could have been Neil and Owen plus Sarah. Or it could have been John and Owen plus Sarah. Or it could have been Neil and John plus Jermaine. Or Neil and Owen plus Jermaine. Or Neil and John and Owen plus Jermaine. So we could have matched them with any of those people. So this is 3 ways and another 3 ways, and together that's 6 ways. Easy way of doing that would be a combination of 3 choose 2 times a combination of 2 choose 1. And if you actually multiply those combinations, this is what we come up with. 3 factorial, 3 factorial over 1 factorial, 2 factorial times 2 factorial over 1 factorial, 1 factorial. All right, so just be short, 3 factorial divided by 2 factorial divided by 1 factorial, that's going to be 3. 2 factorial divided by 1 factorial is going to be 2. Give you 6 ways. Exactly the same number of ways had we actually did it all manually and figure out each different grouping we could have possibly had. So it's just easier to multiply those together. Had we added that, it would be 3 plus 2 would be 5 ways, which would be wrong because it doesn't really work the same if we added those. You do have to multiply them. Anyway, that's all I have. Good luck.